Let's do some Unit 2 problems for MCQ for AP Pre-Calc. We have in an auditorium, the number of seats in a row is 3 more than the previous row. If there are 50 seats in the 15th row, how many are in the first row? So we are going to have 3 more in the previous row for the number of seats. Now the number of seats per row is increasing at a constant rate. So what we can do is we can identify that this is going to be an arithmetic sequence. So if we call the number of seats in a row 15, then A sub 15 is equal to 50, then the number of seats in the first row is going to be A to the 1. Now we have an arithmetic sequence. So what we can do is we can say we have A sub n is equal to A sub k plus D times n minus k. So D is going to be the common difference between, and we have, in this case, D is equal to 3. So let's just substitute that in. We have A15 is going to be A1 plus 3 times 15 minus 1. We get 50 plus is equal to A1 plus 42. We get A1 is equal to 8. Now we're going to have 8 C's in the first row. So your answer is going to be 8 for your first question. The first term of a geometric sequence is going to be 9, and the third term is 4. Identify the common ratio in this sequence. So in the geometric sequence, you have a common ratio R between consecutive terms, which means that G sub 2 is equal to R times G1. Then G sub 3 is equal to R times G sub 2, which is R times G sub 1, which is R squared times G sub 1. Now, if we call the first term G1, we're going to have G sub 1 is equal to 9, and we have G sub 3 is equal to 4. So we have G sub 3 is equal to 4. That's going to be equal to R squared times G sub 1. So that's basically 4 is equal to R squared times 9, and then we just get R squared is equal to 4 over 9. Take the square root of both sides, you just get that R is equal to plus or minus 2 over 3. So we know that all the terms in the sequence are going to be positive. So we have positive terms, therefore we are going to take R is equal to 2 over 3 instead. B. Now for our next question, we have the arc length of a pendulum swing decreases by 10% on each pass. Its initial arc length is A. What function represents the length of the arc n after it passes the initial swing? So if it's decreasing 10% on each pass, that means that the arc length is going to be 90% of its previous arc length, aka 9 over 10. So that means that the arc length on one pass after the initial swing is going to be f of 1 is equal to A times 9 over 10. So then the arc length after 2 passes after the initial swing will be f of 2 is equal to f of 1 times 9 over 10. And that's the same thing as A 9 over 10 times 9 over 10. Now, you can just rewrite that. We get A times 9 over 10 squared. So if we continue this pattern, the length of arc n passes after an initial string. We can write the general as f of n is equal to A times 9 over 10 to the power of n. So that's going to be option C here. The table below represents selected function values for 5 different functions. Which of the following functions can be represented as an exponential function? So we are going to have over equal length input values. We're going to have an exponential function will have change proportionally. So the ratio of the consecutive terms will be equal. In this case, we can see we have equal length intervals, right? Each of these is a difference of 2. So we can notice that we have equal length intervals of 2 units. We're going to check the ratios. So let's do the ratio 5 over 4. 5 of input 4 over 5 of input 2. So that's going to be 8 over 32, right? Equal to 1 over 4. Here you have 2 over 8. That's going to be 1 over 4. Here you have 0.5 over 2. 0.5 over 2, so which is 1 over 4. So because these ratios are equal, f can be represented as an exponential function. Now let's check the same thing for g. Here, let's take those ratios. We have 4.8 over 2.4, which is 2. We have 7.2 over 4.8, which is not equal to 2. And then we see that these ratios are not equal. So that means that g is not going to be an exponential function. This is an exponential function. Now, we can see that for g, we get differences that are equal. So if we do instead a different approach of g of 4 minus g of 2, that's 4.8 minus 2.4, which is 2.4. Now g of 6 minus g of 4 is equal to 7.2 minus 4.8, which is 2.4. If you have g of 8 minus g of 6, that's 9.6 minus 7.2, which is equal to 2.4. So that means that the differences are equal, which means that we are going to have a linear function for g. Now, what about h? For h, we can check the ratios. So if we take the ratios here, we get h over 4, or h of 4, that's 36 over 12, that's going to be 3. Here we have 76 over 36, that's not equal to 3, so automatically that's not going to be exponential. What we can try are the differences. So we have h of 4, or h of 4 minus h of 2, that's 36 minus 12, equal to 24. We have h of 6 minus h of 4, that's equal to 76 minus 36, equal to 40. We have h of 8 minus h of 6, 132 minus 76 is 56. Now the second differences, taking these, that's going to be 16 and 16. So because the second differences are equal, right? These are the second. That means that we have a quadratic for h. Now, what about function j? So function j, we can check the ratios. And conveniently for us, 10 over 0.1 is equal to 100. And 1,000 over 10 is equal to 100. And 1,000 or 100,000 over 1,000 is equal to 100. So this can be represented as an exponential function. So our correct answer for which of the following can be an exponential function is going to be option C, just f and j. The initial number of bacteria in a colony is 500. If the number of bacteria doubles every single day, which function represents the number of bacteria after d days? So we know that since the number of bacteria in the colony doubles every day, we know the number is changing proportionally, which means that we have the need for an exponential function. Proportional change. In general, we have exponential functions are modeled of f of x is equal to a times b to the power of x, where a is going to be your initial value, and b is going to be your growth or your decay factor. Now, we know that the initial number of bacteria in the colony is 500, so a is equal to 500. So we know that we have b equal to 2 because bacteria is going to double every day. And this is your initial amount. So we easily can get our answer as option B here. We have 500 as A, and then we have D here, and then we have 2 here for B. So our next question is, we have given f of x is equal to 4 times 1/2 to the power of x, which is the statements are going to be true about the function of f. So we know the output of exponential functions, output for exponential functions, they are going to be proportional over equal length interval values. Input value intervals. And exponential functions, they're always going to be increasing or decreasing. So let's look at our function here. 4 is going to be the y-intercept, your initial value. And then we have our decay factor as 1/2. So we know that for each increase of 1 of x, the positive function value will be cut in half, resulting in a strictly decreasing function. So this is going to be true. Now, exponential functions are always either concave up or concave down. So it's either concave up or concave down for the entire function. So in f of x, where we have that's equal to 4 times 1/2 to the power of x, a is equal to 4. So because it's 4, we're going to be concave up. So statement 2 is going to be false. It's not concave down. Now, exponential forms of y is equal to a times b to the power of x, they're going to have a horizontal asymptote of y is equal to 0, which means that the function approaches 0 either as x increases without bound or as x decreases without bound. But the function is never going to equal to 0, so that means the statement is going to be false. It's never equal to 0. So for example, we are going to have, for this graph particularly, this is going to be the graph of f of x is equal to 4 times 1/2 x. So right here, that's going to be when we cross the y-axis at 4. But it's never going to equal to 0. It's just going to approach 0. Now, our answer is just going to be option A, only one. For which of the functions is the following statement true? So our answer is going to be 1 and 2 only. 1 here and 2 only. So some of the questions got to cut off. So this is going to be limit x approaches infinity for option 1, which was f of x is equal to negative 0.9. 0.9. Let me just write out all the options. So we have to look at the end behavior of an exponential function for y is equal to a times b to the power of x. It's depending on the signs of a and whether b is 0 or 0 and 1 or is greater than 1. So let's look at these different possible values. Now, all of our case scenarios, if you have f of x is equal to a bx, right? And then you have a positive a, and you have a b in between, your result's going to end up looking like this. What about this case? You're going to have an a that is greater than 0, and you have a b that is greater than 1. You get a result that looks like this. If you have f of x is equal to a times b to the power of x, we get a is less than 0, and 0 is going to be squished between these values. So that's going to look like this. When you have f of x is equal to a times b to the power of x, we get a is less than 0 and b is greater than 1. So that's going to look like this. So for our statement, as x approaches infinity, this means that x is increasing without bound and the function is approaching 0. So we're going to see this happen when we are in this scenario here, regardless of the sign of a. So that means that for our first option here, f of x is equal to negative 0.9 times 0.9 to the power of x, And also for the option 2, f of x is equal to 0.9 times 0.9 to the power of x. These are statements for which this statement is true because we don't care about the beginning part. Who cares? We only care about this middle part. This is in between. So those two match. So only 1 and 2. So for our next question, they're actually over here. So that was just option A. Which of the expressions is equal to this? We're going to use properties of exponents to manipulate this expression. All over 16, this is product property for exponents. We have 54, a to the power of 3, b to the power of 4, over 16. Now we can reduce the numeral coefficients by canceling a factor of 2. 27, a to the power of 3, b to the power of 4, for 8. Rewrite this coefficient as a perfect cube. We have instead of 27, we can do 3 to the power of 3. A cubed, b to the power of 4 over 2 cubed. So all of these terms except b to the power of 4 are perfect cubes, so we can just factor out that b and then use the power property of exponents. We have 3 over 2 ab cubed. So this is going to match with option B. Now given 5 to the power of x is equal to 9, identify the value of 5 to the power of 2 minus 1/2 x. So we're going to manipulate the expression. We get 5 over 2 divided by 5 to the power of 1/2 x. And we're going to use the commutative property of multiplication. We have 5 squared over 5 to the power of x times 1/2. So we're going to substitute the given value of 5 to the power of x is equal to 9, giving us 5 squared over 9 times 1/2. So we're going to use the rational exponent property. We have 5 squared here over the root of 9. And then we're going to evaluate the numerator and denominator. That's 25 over just 3. That's just option C. So in any given week, the demand for a popular item at an online store is increasing at a rate that is proportional to the demand of the previous week. The table below shows the demand for weeks 1 and identify the initial demand that is the demand for week 0. So for week 0, we have a mystery amount of demand. What we can say is we know that exponentials are model growth patterns where our successive output values over equal length value intervals are going to be proportional. So for this context, we know that for any given week, the demand for the item is going to be increasing at a rate that is proportional to the demand of the previous week. So we can model that demand d as an exponential function of the number of the week, which is x. So then we can write this as d of x is equal to a times b to the power of x. With the given information, we know that if we have for the first week d of 1, that's equal to a times b to the power of 1 equals to 72. And also for a third week, that is going to be a times b to the power of 3, which is 162. So let's solve for a using the first equation. So if you know the relation for a, that's going to be 72 over b using this rearranged equation here. Now all you're going to do is substitute that into your second equation. So we have ab cubed is equal to 162, right? We have 72 over b times b cubed. So that's going to help us determine a. We get that a is equal to 48. So then for our exponential model, we plug everything in. We have d of x is 48, 3 over 2, power of x. And also d of 0 is going to be equal to 48 times 3 over 2 to the power of 0, that's equal to 48. This is equal to 1. So that makes sense. So C is going to be our right answer. The value of a rare coin is found to double every 5 years. The initial value of the coin is 100. Identify the function that determines the value of V of the coin after X years. So how do we do this? We know that the growth is going to be proportional to the value of the coin, and it can be modeled using an exponential function. We have V of X is equal to A times B to the power of X. So our initial value, V of 0, is equal to A times B to the power of 0, and it's equal to $100. So because we know that B to the power of 1 is equal to, or we know that B to the power of 0 is equal to 1, A is equal to 100. So we know that the value is going to double every 5 years. So we have V of 5 is equal to 100 times B to the power of 5 is equal to 200. So B to the power of 5 is equal to 2. Now we're going to raise both sides to the power of 1 over 5. So we have B to the power of 5 over 1 over 5 is equal to 2 times 1 over 5. So B is equal to 2 times, or 2 to the power of 1 over 5. Now, if you plug into V of X, you have that's equal to 100 times X, or 100 times 2 times X to the power divided by 5. So then, in general, if we have a function of any form, like f of x is equal to a initial to the power of x over n, this is representing a quantity of an initial value of a naught, and that's going to be changing proportionally by a factor of m every n units of x. So in this case, we have a naught equal to 100, and then m is 2, and then n is 5. So that's going to be this option right here. Given f of x is equal to x plus 3 and g of x is equal to x squared minus 2x, identify this composition. So it's not too bad. It's just a little bit of algebra. So let's just move this down over here. This is for question 12. So that's going to be the same thing as f composing of g of x. So that's going to be equal to x squared minus 2x plus 3. This is going to be x squared minus 2x plus 3. So then other way around, this is going to be gf of x internal. We are going to have x plus 3 squared minus 2 times x plus 3. This is x squared plus 6x plus 9 minus 2x minus 6. This is x squared plus 4x plus 3. Now let's try this. We have f composed of g minus g composed of f. So that's just taking both the things we just found and subtracting them. X squared minus 2x plus 3 minus x squared plus 4x plus 3 is all going to end up equaling to negative 6x. Now for 13, we have given the graphs of y is equal to f of x and g of y is equal to g of x below. Evaluate f composition of g with the input of negative 2. So that's going to be this graph here. And in order to evaluate this, we can see that from the graph, when we have g of negative 2, that's going to equal to 4, and f of 4 is equal to 6. So if we compose the two, we have f composition of g, composition of negative 2, so that's going to be fg times negative 2, that's equal to f4, that's equal to 6. Because here at f, you can see that you have f of 4, at the x value of 4, you have it equal to 6. And then here, when you're at g of negative 2, this is equal to 4. Now, your answer is going to be D here. Given this, we want to find g of x. So, all we can see is here, for f of x, we have that, right? So if we have g of x equal to x minus 2, then f composition of g with x inside, that is going to be equal to, first, f of x minus 2, right? So this is going to be 1 over x minus 2 squared plus 3 times x minus 2. And you have 1 over x squared minus 4x plus 4 plus 3x minus 6. So this is going to be 1 over x squared minus x minus 2, which is given. So that's already given, right? So that means our answer is going to be option B. So that option works. Basically, we just substituted in option B and saw if we got this as our answer, which we did. So automatically, all the other options are going to be wrong. The table below gives a few input and output values of a continuous linear function. Evaluate f negative 1, input of 4. So what we're going to do is, one way to determine inverse functions is we are going to switch the input and output values. Determine inverse by switching the input and output variables and solve for the new output variable. So this is the function, 4 minus 2x over x plus 3. That's going to be y is equal to 4 minus 2x over x plus 3. So swap x and y. Now we have 4 minus 2y over y plus 3. So solve for y again. We have cross multiplication here. We get x times y plus 3 is equal to 4 minus 2y. Now distributing, we get xy plus 3x is equal to 4 minus 2y. And you have xy plus 2y is equal to 4 minus 3x. Y is equal to x plus 2, and you have 4 minus 3x on this side. So after this, we can write y is equal to 4 minus 3x divided by x plus 2. X plus 2, this is x plus 2. And we have inverse now. We can replace y with the inverse symbol. So we have 4 minus 3x all over x plus 2. So let's see which one this matches with. This matches with option D.